Okay, here we got regular geometry. This is Unit 4. It's probability stuff. Question 110. So when he was in first grade, Harvey played games with spinners. One game he especially liked had 2 spinners and several markers that you moved around a board. So it's like a board game, basically. Okay, you were only allowed to move if your color came up on both spinners. And so there's the spinners set up, and I've already set up a area model here. Let's get this out. I've already set up an area model. So here's the one spinner, right? So half chance of landing on yellow, quarter chance of landing on green and purple, and the second spinner is going vertically with a third chance, or 1/3 chance for each of those, yellow, green, and purple. So I've already figured out all those probabilities using an area model. It says Harvey always chose purple because that was his favorite color. What was the probability that Harvey could move his marker? Okay, so let's go back and check this out. So it says you can only move if they land on both colors for each spinner. So we're looking for the purple-purple, right? When purple matches up with purple. In this case, it's a 1/4 chance times a 1/3 chance there, which is a 1/12 chance. So the probability that he could move is right here in this box right here, purple and purple. That's a 1/12 chance. So there we go, 1/12. Is the event that Harvey wins a union or an intersection of events? It's going to be an intersection because it requires it to be for both spinners. If it was a union, then it would be the purple probability of one plus the purple probability of the other. So 1/4 plus 1/3, but that's not what's happening here. It's an intersection because it requires both of them to happen at the same time. So it's where those probabilities overlap. So it's the 1/4 of purple chance in one and the 1/4 purple chance in the other. So like it's not or, it's an and, which makes it an intersection. And then we got, let's see, was purple the best color choice? Explain. Let's go back to our probability chart here and see. Okay, so the probability of them both landing on purple, so purple-purple, was 1/12. The probability of them both landing on green was 1/12. The probability of them both landing on yellow was 1/6. So I would say that purple is not the best choice. It's the same probability if you were to choose green, but yellow is the best choice since that has a 1/6 probability of happening. So I would say that yellow is because there's a 1/6 chance versus a 1/12 chance for yellow ones. If both spinners are spun, what is the probability that no one gets to move because the two colors are not the same? Okay, so let's go back to here. So we're looking at all the instances where the colors don't match up. So we have in this first row here, yellow and green, yellow and purple, so that's 1/6 plus 1/6. We have green, yellow, and green, purple, so that's 1/12 plus 1/12. And then down here we have purple, yellow, purple, green, which is 1/12 plus 1/12. So 1/6 is actually 2/12, right? So we can combine these together. So 2/12 plus 2/12 plus 1/12 plus 1/12 plus 1/12 plus 1/12. So we get 1, 2, 3, 4, 5, 6, 7, 8. There is an 8/12 chance that no one gets to move, which is also like a 2 that reduces down to 2/3 chance. So it's like a 66.6% chance that no one gets to move. So 8/12 or 66.67% chance that no one gets to move. Part E says there are at least 2 ways to figure out part D. Discuss your solution method. Okay, well I figured it out by looking at all of the instances where the colors were different and adding them up. The second way would be to look at the instances where the colors are the same, 1/6 plus 1/12 plus 1/12, so yellow, yellow, green, green, purple, purple. If we add those together, once again, that's 2/12, so 2, 3, 4, that's 4/12, which is 1/3. And so one way you could do it would be to add up all of the boxes where they were different. You get 8/12 or 2/3. The second way would be add up all the boxes or instances where they're the same, which is 1/3, and then subtract that from 100%, right? Because we know those have to add up to be the same. So 1 minus 1/3 ends up giving us the 2/3. It's not that one way is better than the other, maybe a little bit easier to calculate out the probabilities that would work and subtract that instead of adding up all the ones that are different, but you get the same thing. And if you have any questions about how any of those things work, those probabilities, feel free to leave a question or comment. Otherwise, you're more than welcome to like, subscribe, or share to our videos.